Saxon's Calculus Lesson 31 is about binomial expansion, recognizing the equations of conic sections. So I started off by going ahead and reminding you what the formula was that you learned in Trig class for if it says something like find the 10th term of, and you start out with the parenthesis with parts with F and S. And so originally when we learned this, we did a Pascal's triangle where we did 1, 1, 1, and then we were adding 1, 2, 1, 1, 3, 4, 3, 1, and so on. And of course, the first one that started with the 1 was for the exponent of 0, and then 1, 2, and 3, and so on. And we did a chart down to about 10, which you should have had in your notes. And then we learned this lovely shortcut to find the coefficient instead of using Pascal's triangle. This formula with the factorials provided us with the coefficient. And then originally we did an XY chart where whatever the exponent was, like if it was to the 5th power, 5, 4, 3, 2, 1, and 0, and then for the Y, 0, 1, 2, 3, 4, 5. And then if you wanted the third term, you counted over 3 and you pulled the 3 and the 2. So what we discovered was that in the formula, whatever this first piece is that gives you the exponent to the first part, the x part, or in this case f, and then this was the exponent to the second part, so I didn't even have to do this chart. This took care of overriding everything. So now that we have that, look at example 1 on page 168 where it says write the first 4 terms of, and it gives us x plus change in x to the 7th power, and it wants the first 4 terms written out. So we're going to do to figure out, well, I know the first one's going to be 1, but I don't know the others, but I'm going to go ahead and just show you the formula anyway. So we're going to start with our 7 factorial for the numerator, and then this one would be 7 minus 7 minus 1, because it's the first term, plus 1 goes back to 7. So that's 7 factorial. And then, I feel like I'm saying that backwards, like it should be 6. 7 minus, I don't know why I freaked myself out there for a split second. I am saying it correctly because the first term then would be 7 minus 1 is 6, plus 1 goes back to the 7, and then 7 minus 1, no, sorry, first term. First term minus 1 is 0, and then that doesn't matter. And 7 factorial over 7 factorial makes the very first exponent 1, which I know it's supposed to be. And then if I follow here, I know that this first term, the x, gets the exponent that matches here, which was the 7. And then the second one, which is in this case change over x, gets the 0, so it doesn't matter, it's not there. Plus, now let's do this, that was second term. So 7 factorial over 7 minus 2 is 5, plus 1 is 6 factorial, and then this one would be second term minus 1 is 1 factorial. And the other thing I can do is I realize that it's fitting a pattern, so if this one was 7, I don't really have to recalculate it, I just do 6. See, it's following this pattern of dropping and climbing for these exponents. So since this one was 0, this one is 1. Okay, so now let's match these denominators with our x to the 6th and our change in x to the 1st power, so I don't really need it, plus the third one is going to be that same 7 factorial over 5 factorial, 2 factorial. So you see I'm just using the pattern, I'm not even figuring out the math. And then this one would be x to the 5th, and then the change in x to the 2nd, plus first, second, third. Okay, so I do need one more. 7 factorial over, so then that one would be 4 factorial, 3 factorial, and then x to the 4th, and the change in x to the 3rd. And then we just need to simplify all of those, right? The first 4 terms, yeah. Okay, so this first one then, those are going to cross off, and we know we're just keeping x to the 7th plus and then 7 factorial loses the 6 factorial and down, and the 1 factorial doesn't matter, so that makes the coefficient 7, and then x to the 6th change in x plus, and then this one, 7, 6, and 5 is lost. 7 times 6, but it's dividing by 2, so that's going to reduce my 2 and my 6 down to a 3, so 7 times 3, oh, they didn't even write the full coefficient. That one should be, though, like 20, sorry, harder to hold in my head. 7, 6, don't need the 5s, 2, that goes to 3. Oh, yes, the denominator's gone. That's what I couldn't hold in my head. So 7 times 3 is 21. And then your, what was this one? X to the 5th change in x squared plus, and then the last one would have been, and you'll see in the book that they actually just left them in 7 factorial over 4 and 3, but I mean, technically it should be worked out. So then that would be 7, 6, 5, 4 is gone, 3 and 2, and the 1 is irrelevant, so 3 and 2 make 6, so 7 times 5 is 35, and then my x to the 4th and my change in x cubed, and that is the first 4 terms. Ooh, tight there. And now example 2. Find just the 8th term of the expansion, and this goes back to f plus s, which is going to match their example, to the 12th power. And we want the 8th term only. So we're going to do 12 factorial divided by 12 minus 8 plus 1 factorial, and then the 8 minus 1 factorial, and we'll have s to the, and let's go ahead and figure this number out. 12 minus 8 plus 1 is 5, so that exponent will be 5, and then s to the 7th, which was that exponent. And then, did they take it? This time they took it to a number. So they work this out, and most likely I would do it on the calculator. However, we know that this is going to 5 factorial and 7 factorial, so 12, 11, 10, 9, and 8, and then 7 and down is gone, and then this one would match the 5, 4, 3, 2, the 1's irrelevant, and then however I could reduce that down and then put those numbers together. But they tell you that you get 792 f to the 5th and s to the 7th for that answer. Okay, in example 3. Find the 10th term of, and they give us 2x cubed minus y to the 15th power. And we want the 10th. Okay, so we're going to have 15 factorial divided by 15 minus 10 plus 1 factorial, and then the 10 minus 1 factorial. So then this one, the first one, is the 2x cubed, and it gets the exponent of 6 when I work that out. And this one is negative y, and it gets the exponent of 9 when we work that out. So then 15, again, I would just do it on the calculator, but 15, 14, 13, 12, 11, 10. Now I can lose the 9 and below, and then this one would be the 6, 5, 4, 3, 2. Again, the 1's irrelevant. And then whatever I could simplify in here, I end up with as the coefficient. Now they tell me that is 505, 5,005. And then I still have to work this part out. 2 to the 6th power is 2 times 2, 4, 8, 16, 32. I believe that's 32, or did I only do that to the 5th? 16, 32. Oh, I did 64 then. Okay, and then x, 1 base, 2 exponents, I multiply. So 3 times 6 is 18. And then this negative, because this is odd, will be overall changing this to a negative for the whole thing. And then y to the 9th power. There's nothing else to change there. So Oh, yes, there's the confirmation of their 64 there at the bottom. So when we do that multiply together, we finally get negative 320,320, and then the x to the 18th, y to the 9th. No other changes to those. So that is the answer to example 3. Now we move on to part B, and I've gone ahead and written out their review here of equations. And so when we have the equation for a line, and you have heard this reviewed a lot in trig and some already in calculus, but let's just go over it one more time. A line has an x and a y that neither one are squared. They are plane to the first powers only. And it doesn't matter about the rest of the format. It could be an equaling y equals mx plus b kind of format, all of the other line formats, double intercept form, all that loveliness. But as long as these are plain, no exponents, we're dealing with a line. Parabola, this is the format we're used to seeing it in, with a parenthesis that is squared. So one or the other, x or the y, will be squared, and the other one will not be. And when that's happening, same here, x squared and a y that is not squared, then we have a parabola. And it's not about the equal to 0. That's its general format. This is the one where we graph it, but you need to be able to pull and identify what it is just based on either equation. Circles have both x squared and a y squared, and the rest of the pieces, we need to put it in this format. We would complete the square, but just recognize that for a circle, I have an x squared, a y squared, and their coefficients are identical. In this case, implied ones, but these numbers must be identical. Then in this format, the center has changed to be like 4, 2, rather than 0, 0. But again, I have an x that is squared and a y that is squared, and they have the same coefficients in front. And of course, in this format, this is the radius squared is 9, so the radius would be 3. For an ellipse, I have an x squared and a y squared, but these numbers are no longer the same. I can have other parts where I can complete the square and solve. This is the other format, its standard format, where the center would be -2, +3. But again, I have an x that's squared and a y that's squared. Now, this is not as easy to see that their coefficients are not the same, but if the denominators are not identical, then you know that if you were fixing this one, you would be flipping this over and putting it up top, which would make it a 3, and this one would be 1/9 in front here, so they're definitely different. Hyperbolas have x squareds and y squareds. Doesn't matter what their other numbers are. We would have to complete the square to turn it into this format, but here's the difference with these. Coefficients are likely to be different, don't have to be different, because it's the minus sign that is important here that makes it a hyperbola. So the major differences are all of these, parabola, circle, ellipse, and hyperbola, have things that are squared. In the parabola, only one of them is squared. In the circle, both are squared. It has a plus sign, but their coefficients are identical. In the ellipse, still has the plus sign, but the coefficients are different. In the hyperbola, it's a minus sign on one of them that is critical. So then, the final example, example 4, on page 170, gives me these equations, and it says, identify what these things are. So, I begin by looking. I have a 4x squared and a 36y squared. So an x squared and a y squared, so we're down to these. Coefficients are different, so that has eliminated the circle. And I have a plus sign, so I know it's not hyperbola, so it's got to be an ellipse. B has an x squared and a y squared. This one's a 9, this one's a minus, so as soon as I see the minus, I know that I have to have a hyperbola. This one has an a y squared, it's negative, but I don't have an x squared, so it's not a hyperbola. This has a plane x, and I realize it has a plane y, but if one of them is squared and one of them is not, then it is a parabola. We have an x squared and a y squared. There's a plus sign. So I know I'm dealing with either ellipse or circle. The coefficients are the same. Therefore it has to be a circle. And finally, I have an x squared and a 36y squared. I had trouble writing that number. So this is an implied exponent of 1, and this is an exponent of 36. So the coefficients are not the same, so that takes me back to being an ellipse.